Hello there, Captain Roundface McPug, coming live from a YouTube recording. As I continue my COVID-19 days sealed away in this car, doing my once-a-day exercise of going to the shops for some essential bread and milk, which frankly I'm not expecting to find any bread and milk, but still. This morning it's been announced that our Prime Minister has the COVID-19 virus, which frankly was an inevitability. Not surprising. I did tweet a rather childish kind of fist bump, and then I thought better myself. I'm not above that, but it's not really a thing for Twitter, I think. It's a thing for the pubs. Anyway, I've been thinking about floating point numbers again. And I've been poking around with, I love my, I've got a ZX Spectrum. I love my Spectrum. It's nostalgia to the max for me, and I've got this piece of code that takes text and turns it into next basic, which is flavor of basic. Sorry, slam on the brakes there. And basic, it stores the tokens, like thank you, things like print and let and for as tokens. Basically, it doesn't store the word print. It stores like hex F5 is print, for instance. F1 is let. I haven't memorized them all, but still. And then on top of that, it stores floating points inside of the basic file. So I've been trying to get it so that when you write the number 0.078, my code correctly in JavaScript encodes the floating point in a ZX Basic or ZX Spectrum Basic, whatever, format correctly. And oh my god, I've been doing this for months. I did a video on floating points some time ago, and just kind of how interesting it is, like how floating points are stored in binary, and kind of understanding how it works, and because binary is 0 and 1. How do you like, you can store integers just fine, but how do you store floating points? And I now know how generally floating points are stored, but the Spectrum stores it in a funny way. Spectrum stores it in a 5 bytes. It stores the exponent in the first byte, and then it stores the mantissa, which is in scientific notation, it's the 2.3 part in scientific notation. The mantissa in the 4 bytes that follow, and then it puts the sign in the first bit of the first byte. And its reasoning for that is that the first bit of the mantissa will always be 1. And the way that works is that somehow it stipulates that the mantissa can only be between half and 1, which would then mean that I just saw some truck drivers go past with masks on. Which means that the mantissa, a fraction in floating points, half is stored as 0.1, a quarter is stored as 0.01, and then 3/4 is stored as 0.11. Right, so the more away from the period you go, the value is half each time. So it's not like half is 1. You get half, and then a quarter, then an eighth, and then 16th, and so on. So that's how it stores the float. And I can take the raw format the Spectrum stores and take that those hex values and turn them back into floating points. But god damn, I can't take a regular floating point in JavaScript, and I can't convert it into the right format. And I think it's because of this kind of condition that says that the mantissa needs to be between 1/2 and 1. And I don't know how to get a mantissa that is that value. And I think I've learned recently that I learned the definition of the word rote. Learn by rote, basically just repeating it until it goes into your head. And I think I'm confident that's how I learn, and it is horrible. Like, why can I not like read some academic paper of sorts and then just go, yeah, okay, I now understand how that thing works, instead of, oh my gosh, Asda is busy. I mean, I guess everyone's at home, but Asda is busy. Why can't I understand how to store a goddamn number? Nuts. Anyway, so that's what I've been doing. And I'm going to go and risk the shops. Try and find bread and milk. And straighten out this lady is. I'm going to drive into her trolley. All right. Okay. Well, hope you're safe and well. Laters.